The only numerical approach we currently have for finding limits is to use a table in order to determine what our function is doing around our indicated x value. You'll see that our function is f of x equals x cubed minus 1 over x minus 1, where x cannot equal 1 because we have a domain restriction. Our table is asking us to find out what's happening to our function f of x as x approaches 1 from both the left and the right. Therefore, the limit notation of this problem would look like this. The limit as x approaches 1 of our function x cubed minus 1 over x minus 1. I'd now like you to take a minute and plug in all of the x values in the table and find the associated function values, and figure out what our function is approaching as we get closer and closer to 1 from both the left and the right. When you're done, come back and we'll discuss it. Here's what your table should look like once complete. You'll see that x approaches 1 from the left. As it does so, our function value is getting closer and closer to 3. The same thing is occurring as x approaches 1 from the right. So our function is approaching 3 from both the left and the right. But can x ever equal 1? We're told right here that x cannot equal 1 because then our denominator would be equal to 0. Does that have an impact on our limits? The answer is no. Even though f of x is undefined at x equals 1, we can still have a limit. The existence or non-existence of a function f of x at x equals c has no bearing on the existence of the limit as x approaches c. We're now going to take a graphical approach to finding limits.